Hello, hi, myself Dr.P.Shivaranjani, Academic Coordinator, Department of Graphics and Creative Design and Data Analytics. So we'll discuss about logical gate. In logical gates, we are going to discuss first about the definition about the gates. Logical gate is a device that acts as a building block for a digital circuit. They perform basic logical functions that are fundamental to digital circuits. Logic gates are used to carry out the logical operations on single or multiple binary input and gives binary output. In simple terms, the logic gates are the electronic circuit in a digital systems. So these are the different types of logical gates. So basically it has been divided into three different types. The first one is called as basic logic gate, and the second one is called as universal gate, and third one is called as other logical gate. In basic logic gates, we'll have a AND, OR, and NOT. So these gates are called as a basic gate. From that basic gate, with these three basic gate, we can derive a universal gate named as AND gate and NOR gate, and there is also another gate called as XOR gate and XNOR gate. So we'll discuss detailedly in the session. So this is the logical diagram for AND gate, OR gate, and NOT gate, or we can call it as invert, and the corresponding Boolean function or Boolean expressions and the corresponding truth table. So we'll have two inputs named as X and Y, and we'll have the corresponding output as F, and the function and the truth table for the AND gate is if both the inputs are same, that is if both the input is 1, then the output will be 1, otherwise all other value will be considered as a 0 values. So that is the truth table for AND gate. And in the case of OR gate, it is represented by taking two inputs with R symbol and gives the single output, and it can be represented in Boolean function as F is equal to X plus Y, and the corresponding truth table for the OR gate is in any one combination of the input there should be 1. If it is 1, then the output will be 1, otherwise it will be considered as 0. So here in the case of X is equal to 0 and Y is equal to 0, then the value of F will be 0, whereas in the case of 0 1, we'll have the output as 1, 1 0 and 1 1 will have the output as 1. That is, in any one combination, if you have get the input as 1, then the corresponding output will be 1. In the case of NOT refers to inverter, or we can call it as inverse. So F is equal to X dash, it takes only single input. So if the value of X is equal to 0, then the inverse is opposite, that is 0, and if the value of X is equal to 1, then the inverse of X dash is equal to 0. So this is the basic gates, and we are going to see buffer. Buffer is nothing but a temporary storage, that is it can be represented with a inverted triangle symbol. It gets one input and it produces a corresponding output. It is just a temporary storage area. So here the Boolean function for buffer is F is equal to X, and the corresponding truth table for inventor is if the value of X is equal to 0, then F is equal to 0, and if the value of X is equal to 1, then the value of F will be 1. And in the case of NAND gate, it gets two input and it is an inverse of AND gate. So the Boolean function for NAND gate is F is equal to X into Y dash. So here since we have mentioned already, NAND gate is an inverter of AND gate, so it works under the reverse principle of AND gate. If both the in the case of AND gate, if both the input are 1, then the output will be 1, whereas in the case of NAND gate it will be inverse. So here the truth table for the NAND gate is if the value of X is equal to 1 and Y equal to 1, in the sense it will have the output as 0. The remaining case will have the value 1. Whereas in the case of OR gate is the inverse of NOR gate is an inverse of OR gate, so it can be represented as x plus y the whole dash. So since it is an inverse of OR gate, so we can see that the principle of OR gate is in any one combination of the input, if the value is 1, then the output will be 1. So it performs the inverse operation in the case of NOR. So if the value of x and y equal to 0, the value will be 1, wherein remaining cases all the value will be 0. The next case is the exclusive OR. So this is an inverse of XR, that is inverse of NOR gate. So it is here we'll use a logical diagram of OR gate with an inverted symbol, and it is been represented by plus, that is XR is been represented by a plus rounded symbol. So here the value of if the value of x is equal to 0 and y is equal to 0, the value will be 0, and y equal to 1 and x is equal to 1, then the value of f will be 0. The remaining cases it will have the value 1. So in the next case is exclusive NOR. So it is an inverse of x NOR. So here we can represent it as with an x plus NOR symbol, the complement. So it will be act as the inverse of XR. So here we'll consider a simple logical diagram for Boolean expression. So here in the Boolean expression we can see that we have 4 inputs named as A, B, C, D, and A dot B dot C. So if it is dot, it will be represented by AND gate. So and the value of C is inverted. So here we have to connect the value of C, we have used the value called as inverted, called as bubble in front of the variable C. So the next one is A, B is inverted, and that has been inverted to D plus, and the value of B bar plus into C bar D. So this is the corresponding Boolean expression for the logical diagram. So similarly we can draw a logical diagram for Boolean expression. So A plus AB into B plus BC into C plus AB. So here we are taking 2 inputs named as A, B and C. So first we are adding, that is A plus B. So for that we have used AND gate, A plus A dot B. So for that in first cases we have used AND gate and OR gate. And similarly for B plus BC we have used for B and C AND gate, and it should be the value of BC will be placed with the OR gate. So B plus BC. So similarly C plus AC. So the value of C is inputted along with AB. So we'll get the corresponding output, and all the values are putted into a NAND gate, that is AND gate. So since we have mentioned as dot, if we are using a dot symbol, then AND gate will be used, and if you are using a plus symbol, we have to use an OR gate. So that is a simple logic. So these are the some of the assessment questions. So just go through it and we'll have a discussion on our class. So these are the reference. Thank you for your patient listening. Thank you all.